Hello, dudes and dudettes. Welcome to this tutorial on randomized search CV with Scikit-learn. My name is Jean-Christophe, and I'm going to teach you how to do cross-validation in Scikit-learn. Randomized search CV is similar to what grid search CV is, but if you want to know what grid search CV is, just look at my tutorial on the topic. But essentially, what it does is that it will test different hyperparameters values for your model, but it handles scalability better than grid search CV by using random parameter value instead of trying all the possible fits. Let's look into how very quickly how this works. So essentially, cross-validation, what it does is that it will split in the number of splits that you tell and the number of folds that you tell, and it will take a validation set here and will try this test and get a metric and do it again, get another metric and figure out what is the optimal number of parameters that you need. So if we look at how grid search CV used to work or does work, is that if you have a machine learning model like KNN, for example, you want to provide parameters like the number of neighbors. So in the first fold, it will get an accuracy score, and then you can get the mean accuracy and figure out that the best number of neighbors for your model and your data set is 3 in order to get the optimal accuracy score. So if we look into this, that's again a primer. I have a tutorial on Grid Search CV and how it works, but essentially Grid Search CV does what I just showed you here. And so when we look at the code, we load the data set, we split into testing and training data set. We instantiate a model without any parameters in this case, and we provide a parent grid that we are going to test with grid search CV. And then we train the model not on the original KNN, but the new cross-validation KNN, and we fit the training data and we figure out what are the best parameters and the best score. And in this case, we get a result where the best number of neighbors for this data set is 5, and the accuracy of it is 91. And we've seen in the previous tutorial that grid search CV doesn't scale that well. If we have a lot of number of parameters, like right now, what we did is we had only 4 parameters, and we tried every possibility, and we extracted the best accuracy score. But when we end up with not 5-fold, but 10-fold, for example, and we start adding more parameters, let's say we want to try 7 parameter value on a tenfold, you can see here that very quick, it's hard to scale because what you would do is you would need to train the model almost 800,000 times just to have 7 parameters. So what if we talk about hundreds of parameters? That's not something that's achievable. And this is where random search CV comes uh, into play. So we will make an example on the breast cancer data set. And the breast cancer data set, what it does is that it has a bunch of features and we try to predict the target variable at the end. And if we look at these features, we can see that the target are malignant and benign. We're trying to predict whether breast cancer is malignant or benign. So we transfer this data into arrays with the X and Y data. Y is what we try to predict. X is the feature input features. And let's start into how this works. So the first step is we want to split our data into training and testing set. So we do X train, X test, Y train, and Y test. So we generally do this to be able to evaluate the accuracy of our models. So let's do train, test, split. If you don't know how this works, I have a tutorial on the topic, but so I'm not gonna go too deep into this, but we're gonna keep a test size of 30%, and we are going to put a random state of 42 for reproducibility, and run this. So essentially what the grid search CV will take is it will take from the training data a validation set in order to do those folds that we talk about. So if we want to perform randomized search CV on KNN, we go with this step by instantiating the model. Generally, when we instantiate a model, we provide the parameters. So in this case, we would provide n neighbors equal 3, for example. But here, that's not what we want to do. We don't know the number of neighbors that we want to have, so we're not going to provide this information. What we're going to do instead is we are going to provide a param grid, and the parameter grid is a dictionary where we define what is the parameter that we want to try. And we are going to use NumPy a range from 1 to 50. So I'm going to have 50 values that I want to try. So import NumPy as NP. I forgot to import the model. So I'm going to have a range of 50 value. So if we come back here, we can see that we had only 7 and we needed 800,000 fits. So with 50 values, that's a lot more than my computer can handle. So I'm gonna do use the randomized search CV instead of all of them. How we do this is we set the variable where we want to do this, and we use the randomized search CV from model selection, and we provide similar parameters as what we did with grid search CV. So we provide the original model, we provide the param grid, we provide number of iteration. Let's say we want to do 10 iteration and limit ourselves to that. We will do 5 cross validation and scoring accuracy. And we are going to provide random state again, just to tell us, just so that we can reproduce the results. So here the scoring, we can use like precision, recall, F1 score. Here we can use a number of cross validation that we want. We can limit to however many iteration that we want. In order to keep that simple, here those are the parameters I'm using. So we run this, and generally when we do a model, we would use knn knn.fit. But again, that's not what we want to do. In this case, what we're going to do is we're going to use the random search class instead of the KNN class in order to train the model. So we use random search.fit, and we select the xtrain and ytrain. So we use the training data to fit the model. We run this, and now we have a trained model. Here, what we want to do, we want to find what are the best parameters. So we use our trained model, and we say what are the best params. And we want to know what is the best score as well. So the best score will be based on the metric that we decide. So here we decided accuracy score. And so the best number of neighbor here is 14. And the accuracy score is 91. Remember, when we looked at the original grid search CV, we could only provide 4 parameters. We could have put as many as we wanted, but here we forgot to put 14. We didn't know. So in this case, our model gave us that 14 value, and it didn't have to go through all the 50 possible KNN value. It just picked up a few at random. If you want to optimize this, you can increase the number of iteration. Now that we've run this, we might want to evaluate the best model. So we say best KNN equal random search. So that's our trained model. And we use a best estimator attribute, which tells us the best model, which is essentially it picks up the model that performs the best, and now we can use this to predict y. So we use this, we say best KNN, we use the best model that we have, and we predict X test. Not the best model, but the model with the best parameters that we have. And then we use this to test the accuracy. And we can say best KNN dot score, and we say X test, Y test. And then we return the test accuracy, and we're gonna play this like this. So we show the we figure out which is the best, the model with the best parameters. We use this best model to predict y, and then we check the accuracy, and then we figure out that the accuracy is now 96%. If you want to add more parameters to the grid, it's possible because KNN has multiple parameters. For example, in KNN, if you look at my tutorial on this topic, you can use n neighbors, but you can also use different weights. So by default, we use the uniform, but we can also look at the distance metric. We can also look at distance metrics like Manhattan and Euclidean, um, and compare all of these. So you just put more of these parameters here in the parameter grid. You do the same step that what we just did, nothing changed here, and you run this, and your best parameters will tell you not only the best number of neighbors, which earlier was 14, but now it's 5, and those are the uniform metric, and the test set accuracy is 96%. So that's it with randomized search CV. So I hope you enjoyed this tutorial, and make sure to subscribe and look my website or follow me on social media. See you next time. Bye.